LVM is incredibly cool stuff. It allows you to take a bunch of block devices, group them together, and do advanced functions on them. Things like taking advantage of different properties of different types of devices, expanding and contracting devices on the fly, and even moving things around and mirroring. I'm going to do a quick example of moving things around, taking advantage of an SSD, live adding devices, pulling them out. And then I'm going to do an overview of LVM and the things that I did. And finally I'm going to end up with story time. I'm doing some live plugging of devices here. I don't recommend that. I'm professional on a closed course, messing around in my shop. If you're going to be live plugging a production server, definitely use a device or an enclosure designed for that. So stay tuned. Alright, let's check out some cool shit here with LVM. My root partition is 25 gig. Oh. And I've got quite a bit free. It's a 500 gig disk. I've got 439. It says gig free. I've used 25 gig. And of course I could resize, LV resize that file system, my root file system. Everyone knows that. You can resize it with LVS. You can resize it hot with ext2. That's no big deal. I've got over here, got this Intel ancient SSD. This is one of those old SLC SSDs, 64 gig. I mean, it's pretty old. 64 gig SLC, which they only made SLCs for a while. They were very expensive. I got this off eBay, probably 5 years ago. It's been sitting on my workbench in the garage ever since. Let's see if it even works. So, power, data. Alright, we have a bunch of disks or hosts that we could rescan. Looks like we can. Alright, 60 gig down here. That's 64 bajillion right there. So 64 gig, and we have our SDA is 500 gig. So we can pv create dev SDB. I'm just going to do the whole SDB because this is messing around in the shop. Oh, it's excluded. And I'm going to say yes because I don't think there's anything interesting on there, at least nothing I know of. So now we can VG extend VG0 with dev SDB2. So we are now adding that new disk, that SSD, into the array. Now the existing disk is Western Digital Blue 500 gig, and that's where my root file system is. And if we look at the memory utilization, we can see there's some space in caches. So if I echo, if I echo 3 out to the drop caches, that should show our caches are smaller. And if we do a find, time of find, looking for a name that doesn't exist, but let's just look through the root file system, And this looks through all the metadata, which is a very random I/O heavy process. Let's run that and see how long that takes. That's why we're timing it. Find xdev means don't walk through other devices like the RAM disk or proc or dev, sys, any of those. Just walk through that spinning disk. And if we look over here, it's reading some blocks, about 1 to 6,000, mostly 1 to 2,000. No, it's jumped way up here. And in this waiting column, we're seeing 9%, often 9% being used waiting for the disk. It took us 50 seconds to read through the root file system metadata. Now, here's a cool thing. pvmove dev sd, what is it? SDA3 to dev SDB2. So we can live migrate the blocks on our root file system while we're using it from that spinning disk over to that SSD. And it'll probably take a while. This is a sequential operation, so we're reading pretty quick, 100,000 blocks per second. And, we aren't that heavily in CPU waiting for disk. So we're cruising right along. I often will run VMstat when I'm wondering about performance metrics. There are other programs. HTOP is another one I use a lot. But this shows me kind of a history. It shows me block I/O. It shows me swapping. Running processes is often useful, but really these CPU users, users very important, and waiting and steal. Steal is like, if you were on AWS, you might get resources stolen from your virtual machine, and that's CPU time you can't use. That's my understanding of it. The wait is the important one. If you're waiting for disk, you're I/O bound, you're disk bound in your operation. And we can also kind of see that. It's in the wrong window here. And you can stop and continue that operation, which is pretty cool. pvmove is very cool. We can also run iostat x5. That generally displays a ton of information. Oh, it's a stat. iostat, like I said, it's huge, the output, but it can be very informational. So here we see SDA is, I'm going to just kill it to examine some of this, one line of this, one sample of this information. SDA, we are doing 89 reads per second, 27 writes per second. That's interesting, I wasn't expecting that. But we're reading 45 megabytes per second, which is about less than half of this disk's native throughput. I don't know if pvmove is throttling it. And then SDB, that SSD, we're doing that same amount of writing activity roughly. And these are read and write requests per second. And there's also this utilization. So 30% read utilization. I guess we are actually bounded on the write speed of that SSD. And this is an ancient SSD, so maybe that's why that is. I thought it was faster than that. But maybe it's not for writes. And that move is done. So, if we now look at the free memory, and if we clear out those buffers, and we do that find again, before it was 50 seconds. And you can see this number now has jumped way up. It was 1,000 to 6,000 before. Now it's 16,000, and it completed in 8 seconds. So that's much faster random I/O. Let's move that back. Move. Go from B2 to A3. Let's see if the I/O stat is telling us anything interesting here. Alright, so now we are reading from SDB 217 requests per second. I think that's twice what it was. 100 megabytes, 111 megabytes a second. So that's about twice as fast as it was going before. Utilization 46% on the SSD, 50 on the spinning disk. I think that's mostly an anomaly because that spinning disk is maxed out or near maxed out. I think I've gotten 150 meg. Well, I haven't tested that one, but 120 meg is right in the, or 111 meg is right in the ballpark. I like to keep my audience riveted. She can nap with the best of them. It should be finishing up. All right. I'm kind of typing at an angle here and making all sorts of mistakes. Davinci, so we're going to remove the dev SDB to the SSD from the volume group. I don't know if I have to kpartx delete the partitions from that just to clean up the kernel memory. But what I'm going to do now is disconnect the SSD, drop. Now I'm going to put on my 2 terabyte disk. You know, SATA kind of emulates the SCSI subsystem here, so that's why they're showing up under SCSI host. And that looks like the ST, that's a C8 pin. Just minus L, we have 1.8 terabyte. Oh, this came pre-formatted. Interesting. Alright. Let's PV create. Usually I'd change that type to Linux LVM, but again, we're just kind of screwing around in the shop here. PV create dev SDB2. That writes out the NTFS insert. So the PV create writes out the LVM formatting data, and then VG extend. Del VG0, del SDB2, and for VG display now, it should show, yeah, it's way bigger than it was before. Before it was 439 gigs, something like that. Now it's 2.25 terabytes. So now we can look in that del VG0. We have a root, which is named, the logical volume is called root, and that's where our root file system is. So let's LV extend, and let's use 100% of free blocks. And we will extend dev vg0 root. Alright, now if we look at the VG display, we have very little free. Let's, we went from 2.25 terabyte free, 25 gig used to, I meant to do plus 100% free. So that's why those numbers switched around. So I resized it to the amount that was free. And so it took the allocated off. What I wanted to say was plus 100% free. And now we have 0 free physical extents, and all of them are allocated. We've got a 25 gig root file system, and we just need to resize to fs on slash. Is that right? Or do I have to? I think I have to give dev g0 root. It's going to take a while to write all of these other blocks. Add 4 descriptor blocks. It's going up to 291. If we go over here, I'm sure it's writing stuff all over. Blocking, periodically writing. Alright, so we went from a 25 gig file system with 37% use to a 2.3 terabyte file system on our root mount point without rebooting. We also did a little shuffle where we live moved those blocks over to an SSD and demonstrated higher random I/O throughput. So, pretty freaking cool. LVM is great stuff. Alright, step into my office. LVM is like coffee. We've got this big carafe, and that's our primary storage. That's our disks. You can take littler things and use part of that big disk in these little things. You take my better 3/4. She's got some. Add some more to it. Grow that file system. Stir it all up. Make sure it's good and ready. Here's your coffee. You can use storage of different attributes. We can take a travel mug. You can, it's a little bit dirty. You can transfer that over there. Now we have something that'll stay hotter. It's like moving it over to the SSD from the spinning disk. Here's the SSD in this analogy. Different attributes. We could add another carafe. We've got some more storage here. You can use that to fill up these different vessels. This is low caffeine decaf. These are our 2 disks. Once we're done with one, we just get rid of it. If we have everything out of it. If we're done with something over here, we can pour it back in. That's kind of disgusting. I'm not going to pour it in there. But pour it back in. That's like evacuating it. And we have that storage back. We can put it into another logical volume. These are our logical volumes. That wasn't clear in this analogy. Logical volumes, physical volumes. So there you go, coffee. Let's explain it with paper. I'm going to keep the coffee nice and handy though. LVM takes your big disk, and let's say that's in this case it was 500 gig. So we can split it up, and by default I believe it uses 4 megabyte chunks. So just a whole ton of those all the way along here. And it addresses each of these like 0, 1, 2, 3, so on. Up to 500 gig divided by 4 megabytes, whatever that is, some large number. So then we can take a collection of these, and they don't have to be contiguous, but if you, the way mine was set up, and if you just pull from an empty LVM, it'll use them contiguous, and turn that into a logical volume. And in this case, since we're pulling from 2 different places, we've got some of the storage coming from the one, some of the storage coming from the other. And now when you access that from, you know, this is SDA, let's say, and this is dev VG0 root. So when we access that as a block device, if we access it up here, LVM is translating it up into this block. If we access it down here, it's translating it down here, but it looks like just one contiguous huge block device. And if we add another disk, in this case we added a small SDB, and that was that SSD, and it's chunked up into a bunch of blocks as well. When we add that to the volume group, we can now say, hey, these blocks that represent this file system here, these raw blocks over here, mirror them onto this disk. So the first block here initially points up to 0. LVM can then mirror it down to the first block here, and then break that mirror, and now this block resides over here. And that's what we did when we migrated from the spinning disk over to the SSD. And it just did that for all of the blocks within this device until they were all over here and none of them existed here. At that point, we could have even removed this device and kept running over here, no problem. So that's the basics of LVM. It remaps blocks from a bunch of devices, which themselves could be virtual devices like RAID arrays, MD RAID arrays, which are virtual devices. So SDA in this case might be a RAID 1 array or RAID 5 or RAID 10. Maybe we had like a RAID 5 array, but it wasn't performing well, so we wanted to add a couple disks in RAID 1, migrate some of that data over. You could definitely do that with these lower devices being MD rather than raw physical devices. Now a little bit of story time. I once had a client I was working with, and they had a mail server, well, it was a file storage server, that had 8 3.5-inch disks, the Western Digital Velociraptor, like 10K disks, in a RAID 10 array. It was an NFS server in a cluster, and it was the back-end storage for a bunch of IMAP email nodes. And it had, here's 4 disks of similar size. They had 8 of them in this RAID 10 array of 10K drives, and the file server was just barely able to keep up. In fact, it was starting to fall behind, and they didn't know what to do. And this was years ago. I want to say they may have been 72 gig or something in the 75 gig range as far as size. So 8 of them, 70 gig, RAID 10, that would be 280 gig of storage, of raw, available storage. So something 8 twice the size, 8 drives big. And just about that time, it may have been a decade ago, it was right as Intel was starting to come out with SSDs, and one of their SSDs was a 600 gig. And a friend of mine just happened to have a production sample of that that he was testing out, and so I asked him if I could borrow it. And we shipped it to this client. Drive, the size of this. This is just a 64 gig, but it was the same size as this Intel's 600 gig version. They added this to those 8 drives, and then we did PV move, because it was already in a logical volume. We did a PV move of all of these devices, the storage array, over onto this. The mail server was up and running. Users were accessing it. They had thousands of users. It was a small rural ISP, but they had thousands of users, all accessing their email. Well, as many of them as were awake, whatever. Some subset of them accessing their mail from the active file system. And we start a PV move to this drive that literally fits in my hand from this 8 drive array of 10K disks. And within about 10 minutes, we had enough data over onto this drive that the load on the server started dropping. It took, I want to say, a couple hours, but even with all that drive activity of copying it over, the SSD was just so fast at random access that the load on the server dropped, and just precipitously dropped to almost nothing, until eventually it was just running on this little drive. Little drive fits in the palm of your hand. They had 2 servers, so they ended up taking their backup server, replacing all 8 of these drives with smaller versions. I think they have a 300 and maybe a 150. So I think they put in 8 of the 150s, and just were able to pull out a drive, put in the replacement, do a RAID rebuild, pull out another one, put in a new drive, do the RAID rebuild, and were able to do that while it was, I believe it was even while it was live, but maybe they took it down, then brought it back up and resynced over DRBD, until eventually they had 8 of these drives, and their mail server never had a problem after we started the migration to this. Once they added 8 drives in a RAID 10 array with SSDs, they were golden. That's it for story time. Thanks for watching.